Okay. Hi, everybody. Let's see. I'm just going to pull the slides up. The one thing I will say is, unfortunately, I can't see your questions while I'm presenting. I would love to get a little input and feedback as we're going along here, but we'll just have to wait till the end, and I'll try to leave a good amount of time for questions. What I would say about this presentation is that, like all technologies, AI, generative AI, a hammer, all technologies present risk and opportunities. And if we are going to be serious about adopting generative AI technologies in the long run, in large organizations or any kinds of organizations, but particularly say like in governments, in hospitals, and energy companies, risk management will just have to be a part of that. And we're certainly in very early stages of risk management for generative AI, but there's a long-standing tradition of risk management for predictive modeling, say in the U.S. consumer finance vertical, and about 80% of that is really valid for generative AI. And there are some new interesting things to think about as well. So this presentation is meant to give a tour of some of the potential issues with generative AI, and then what we can do about them as we seek to adopt them inside of our organizations. These slides have been publicly available for several months now. They're up on Google Drive. There's a tiny URL there that you can use, or a QR code there that you can use if you want to access these later. Okay, so I'm not sure how much of this we'll get through. Originally, this was a bit of a longer presentation, but basically we want to establish some vocabulary. And when we're talking about testing a generative AI system, sure, we can just sit down and try to make it say nasty things or make nasty images, but it's much better to have a standard in mind that we want to test against. And we'll get to that. And then when we think about generative AI red teaming, I think a lot of people have this conception of generative AI red teaming as, again, sitting down in front of the generative AI chat UI and trying to make it say something bad or generate some kind of bad image. And I'm going to try to encourage you to think much more broadly about red teaming. So we're going to start from the supply chain. One thing that is truly different about generative AI is it has a much broader supply chain than, a scikit-learn classifier or something like that. So we're going to try to start all the way back at that supply chain, try to find all the different risks and impacts that we can, and then finally mitigate the risk. So we're going to go all the way from the supply chain to the users, and then think about the risk that we found and how we can mitigate them. Okay. So I'm going to be quick on the vocabulary. I think what I'd like to call out here is when I hear people say red teaming, they seem to mean some mixture of audit or assessment or red teaming. And what I'd like to communicate is that there are real definitions for these terms. And there's some issues with communication if we start using these terms too haphazardly, but it's not my biggest concern. But an audit is a real thing. An assessment is a real thing. And I'll highlight that I do work with NIST, National Institutes of Standards and Technology, on AI and generative AI risk management standards. And we've put together a glossary that I think is okay if you're interested in sort of digging in more on the vocabulary. Okay. So red teaming, red teaming comes from the kind of cyber tradition or information security tradition, and it's really supposed to be an adversarial role-playing exercise where experts come in and try to break your systems and let you know what they find. So, while I was just complaining about people kind of using red team and validation and assessment kind of interchangeably, I'm going to be doing that in this presentation. So you can think of the first part of this presentation as kind of a guide to red teaming language models, if that makes more sense to you. And when you hear me say risk, again, I try to mean something specific which is the likelihood of something bad happening multiplied times the impact or the cost when that bad thing happens. And that's a very traditional definition of risk, and hopefully that's what I mean when I say risk. I'll just sit here for another second in case people want to read these definitions. Okay, so again, we can, and I've done this, I've been paid to do this, we can sit down in front of the chat API or, Discord or whatever it is that's the API for the particular generative AI system and start trying to make it do silly things or offensive things or very bad things. But that's not particularly systematic. And that essentially boils down to low in, so not very many tries, one human being can only do so much, anomaly detection. And if you know anything about an anomaly detection, you really need a lot of data to find anomalies. And so I find this general notion of sitting down in front of the chat UI and trying to trick the model as pretty silly and perhaps not very effective. Just like in a good old-fashioned science experiment, we want a control. We want a standard to measure against. That's the first thing we want if we're really going to test the system, really get into the risk, and really get into managing those risks. We need to be measuring from a certain standard. And there are actually good standards now to measure AI systems against. So I'll again highlight the NIST AI Risk Management Framework. This was released in January 2023. It's being updated currently to address generative AI harm specifically, and in alignment with the recent executive order on AI, which would be another great standard to audit or test against. There's the forthcoming EU AI Act that lays out very strong guidance and conformity principles for AI systems. There's many existing laws, data privacy policies, non-discrimination laws. All of these are a benchmark against which to test, right? Just sitting down and trying to trick the model into saying silly things is going to get you a few steps. If you start with a standard in mind and testing against that, you're going to be doing much more of a structured, effective exercise. Okay, and again, like I said, we don't want to be myopic in our testing of these broad application AI systems. As I'm sure you're aware, generative AI systems can make text, make images. They can be used from anything, from helping kids with their English homework to generating child pornography. And, we have to think about the broadness of the application there, which would generally be kind of a risk indicator in traditional model risk management. And we have to think about the broadness of the application. So I like to start thinking about the supply chain. And again, the supply chain is one of these issues with generative AI that is truly different, truly new, okay? And the thing that I would point out about the supply chain is there are a lot of people in the supply chain, okay? And those people bring their skills and talents to the data labeling and the content moderation, but they can, the size of the supply chain can also bring risk along with it. So we have to think about things like data poisoning and injection of malware deep in the supply chain of a generative AI system. Some of us might like to think about ethical labor practices in the supply chain. And for an organization, that can be a real reputational hit if your customers find out that the labor practices for your content moderators and your data laborers aren't quite the same as the labor practices for your developers sitting in the US or the EU. Localization and data privacy laws, these systems take a great deal of data to train. It's getting more and more complex to move data around. Data is more and more regulated quantity, especially throughout the world. Maybe not so much here in the US, but especially throughout the world, data can be highly regulated and you can't just move it around sometimes. And that can present serious problems for training and testing generative AI systems that are so data hungry. Sadly, we live in kind of an unstable geopolitical time, and it's possible that sort of nation state adversaries can be involved in your generative AI supply chain. It's possible that the country where your content moderators or data laborers were working suddenly isn't really a country where people want to work with big tech companies in the United States. These are risks you have to consider. There's always a lot of third parties involved in all big machine learning models. Generative AI models being some of the biggest have some of the most third parties. Any of those third parties can bring software vulnerabilities, hardware vulnerabilities, personnel issues. So if we really want to red team, if we really want to check what's going on and get all the risk in mind for a generative AI system, we just have to start with the supply chain. Okay. We have to stay humble when we're red teaming or auditing these systems. Even people like me who get on conference webinars and supposedly tell people how to do it. We can all get hacked. We can all get pawned. It's just part of the business. But it's really crucial also not to be naive. We just need to admit there's no risk avoidance here. Risk avoidance is naivete. Language models and generative AI systems inflict harm. I saw several disturbing examples just today and reported them to the Department of Justice. Language models get hacked and abused. So your technology can hurt people, people can hurt your technology. And that goes for all technology. AI and generative AI aren't special in that regard. We also have to think about the way we work around generative AI, and are we tricking ourselves? Large black box systems really open themselves up to risk around confirmation bias. Maybe we're just seeing what we want to see in the results. Obviously, there's a great deal of funding bias and groupthink potential around these models, right? If everybody in the group that's making these models gets their funding from the same place, if we're all thinking the same thing, these are potential risks that because of the blind spots that they induce, right? We need to have a very open mind when we're thinking about the potential risk here, and not succumb to blind spots because we want the system to work, because we want to get paid more, because everybody in our group wants it to work. So we shouldn't be naive, and we have to acknowledge that our own biases could make these issues more difficult in some cases. And we have to remember that incidents can happen to anyone, even me. Okay, so what kind of incidents do happen? We really want to do a review of past incidents to get a sense of what's going to happen in the future, okay? Past behavior is one of the best indicators of future behavior. So, these are pretty general incidents that I'm going to go through. If you're working on a specific application, you might want to familiarize yourself with incidents that are more in that application domain. And I want to be clear, I'm not showing these incidents to embarrass people. We study incidents so that we don't repeat them in the future. Those who don't study history are doomed to repeat it. So it's good to look into AI incidents that have happened in the past. Try not to repeat them. Okay, so we'll just go through a few here. I'm involved with an organization known as the AI Incident Database, and we have been tracking incidents for several years now, publicly available incidents in AI systems. In November of 2022, we had, say, 250 incidents, many more reports, but 250 identifiable separate incidents in our database. Since the release of ChatGPT in November 2022, the database has more than doubled in size. Okay, so there were many different types of risk that sort of emerge in that slide. I'm going to call out perhaps the most well-known, and because I think it's illustrative of why we would study past incidents if we're trying to understand future risk. So I'm sure many of you know this is Tay. Tay is the infamous chatbot from Microsoft Research going way back to 2016. And Tay had a brief existence on Twitter in which it started out sort of being a fun chatbot to introduce people to AI on the internet. And the internet, being the cesspool that it is, people realized quickly that Tay was using some kind of adaptive learning mechanism, and that it was very, very easy to conduct data poisoning attacks on Tay. And so people would tweet nasty things at Tay. Tay would incorporate those nasty things into its training data and repeat it with some, little bit of stochasticity injected into it. Tay had to be taken down after about 16 hours, after about 92,000 tweets. And I think that, again, a really important thing to understand about AI incidents is they happen with scale and speed. And so, Tay happened with scale and speed. And also, I would say that the AI incidents can morph. Okay, so I would say that Tay really started out as a security issue, but quickly morphed into sort of a toxicity and algorithmic bias issue. As before it was shut down, it was, just kind of spewing a constant stream of hateful and kind of pornographic material. I like to highlight the sort of similarity between all these higher profile chatbot fails. I'm not sure why we like animated young women with sort of light around their faces, trying to anthropomorphize these systems, which that in itself is a risk. But moving your attention over here to a chatbot known as Leluda. Tay was 2016, Leluda was 2021. And Leluda had many of the same flaws as Tay, plus an interesting twist where its training data wasn't scrubbed of personally identifiable information, and it was handing out personally identifiable information with its sort of toxic foul-mouthed outputs. It's clear to me that the developers of Leluda most likely were completely unaware of Tay and repeated many of those same mistakes, and or didn't care. I can't say which, but for those of us who do care about making better generative AI systems, we could have learned from Tay to prevent Leluda. And again, I just want to highlight just the visual similarity between these two sort of anthropomorphized avatars. This is just to me a very obvious sort of example of a repeat AI incident, and that's precisely what we want to avoid by reviewing past AI incidents. So we review these AI incidents to understand what the most likely risks are in our current system, and then we try to test or red team for those risks the hardest. Okay, we review the past incidents to get a sense of what the most likely risks are. I want to be clear that there's many more people richer and more famous than me in this field, but for my money, acceleration isn't a real risk. Acquiring resources isn't a real risk. Avoiding being shut down isn't a real risk. Emergent capabilities are a mirage. Replication isn't a real risk. Okay? These are big machine learning models, nothing more, nothing less. So unfortunately, they're not going to come alive and kill us all. Okay, I don't worry about that, and I don't think large organizations should be worried about that either. I think generally those are that's a fun new guerrilla marketing technique, and I'll try not to go on and on about it. But these are just big machine learning models. They're not going to come to life and kill us all anytime soon. Nuclear weapons and global warming will kill us much before AI does. That said, there are some real risks with AI systems, today's AI systems. And again, I'll climb back up on my soapbox for a minute and say, why am I not worried about these risks? Well, when the people who talk about them compress it into a fun little marketing term, compressing existential risk into X risk, I think that's the clear sign that we have that this is just marketing. Unfortunately, though, these systems do pose real existential risk, not necessarily to life, but to democracy. These systems, and not just generative AI, but today's AI in general, engaging in real-time automated surveillance, disinformation and deep fakes, social credit scoring. These kinds of applications bite away at democratic institutions. And I think we're already seeing that. So I'm up on my soapbox here, but I'm saying AI coming to life isn't a real risk. AI slowly chipping away at democratic institutions, that's a real risk. It's not something that we're going to red team for, though. What we're going to red team for are things like abuse, misuse, and abuse and misuse, and just for disinformation purposes, automation complacency. So people just get lazy and trust these systems too much. There are myriad data privacy violations with these systems. In my experience, and I use a lot of generative AI systems, and I test a lot of generative AI systems, highly prone to errors. I don't even like to say hallucination. I don't, going back for decades, there's been a ton of hand-wavy language around neural networks, and hallucination and some of these other words that are used to describe generative AI models are just, more in that tradition. So it's not a hallucination. It's an error in a software program. There's intellectual property infringement. There's systematically biased and toxic outputs. And speaking of toxic outputs, I had kind of a troubling interaction today. It does seem that Instagram right now is really in the mood to recommend child pornography and like images of young girls made by generative AI, and that would be a classic example of toxic outputs, and I think a pretty harmful one. And it may be happening on other social platforms. I'm just seeing it the most on Instagram right now. And then there are sort of traditional security and machine learning security attacks. This is what I would be concerned about. The likelihood is high here, and the cost can be high. The likelihood of these are very low, very, very, very low. The impact here is very high, but we're not going to be able to red team for things like this unless maybe we're in the FBI or something like that. So these are the realistic risks to go after, and we want to sort of prioritize risk in this group as the ones to test for the most. Okay. Once we have the risk that we want to go after, there's still some general strategies that we can think about. And data quality is one of them. Okay, so just garbage in, garbage out still applies. And we're starting to have a pretty solid notion of what data quality means in at least text data, and I would say image data as well. And so we should be able to do just some basic screening of the data that was used to train these systems, at least ideally. For me personally, it is a risk if vendors aren't revealing what their training data is. I think that means, if you're an organization that's looking to adopt one of these systems and the vendor isn't transparent about what their training data is, I would knock the risk up one notch more in terms of your thinking about how you're going to adopt this technology. If it's an open source model, if the vendor is being transparent about the training data, you should dig into the training data and make sure that it's high quality, whether it's images, videos, text, audio. And this example here is sort of a taxonomy of some common text data quality problems. And it's from a really interesting paper that's certainly not written by the AI cool kids, but I find it incredibly useful in my work nonetheless, called DQI, Measuring Data Quality in NLP. Okay. There are also benchmarks, both computer vision and NLP over the past 10, 15 years, and probably longer. I've just only been involved for 10 or 15 years. There are these benchmarks that have been developed, and the ones that you see on the screen are particularly useful for me and my work, and they get at bias issues and sort of accuracy issues, and toxicity issues more broadly. So I'll just give an example of the BBQ, the bias benchmark questions. So the bias benchmark questions are a series of questions where the language model is supposed to kind of answer, I don't know, or there's not enough information. And I think kind of the famous example question from this data set is there's roughly, there's an old man and a young man standing outside a store. One of them is struggling with their smartphone, which one? And so the language model is supposed to come back and say, I can't tell. There's no way to tell from what you've said. And so if it comes back and says, oh, the young people are stupid, they don't know anything. Or if it comes back and says, old people don't get technology, you start to get a sense of where there might be stereotyping in the outputs of the system. And so again, I don't want to dig into each one of these. I want to make sure we leave plenty of time talk through questions and to get into some of the risk mitigation approaches. But there's a good set of benchmarks out there that you can and should be applying to generative AI systems to get an idea of what type of bias, what types of toxicity, what type of errors you're going to be looking at when you deploy this system. Okay. Oftentimes, as I'm sure many of you understand, language models are just one part in some broader machine learning pipeline, or even just one part in some broader business process. And whether it's a pipeline or a business process, if it has a numeric outcome or a binary outcome, or even a multinomial outcome, sort of multi-way categorical outcome, we can test it like a regular model. And we like to think that we're at least pretty good at this. Okay. So again, if your language model is the end use of it is some business process that has a yes or no answer, test that yes or no answer. Don't, you may not have to dig into the details of the language model. And if we're testing yes, no answers and we're testing numeric outcomes, then like I said, we like to think we already know how to do this. And so what you see here is an example that I worked on last year when I was involved with an audit of Roberta back in pre-ChatGPT days. I think this may be actually, no one's ever told me I'm wrong, so I'll say it again if somebody can tell me I'm wrong. I think this was the first commercial audit of a large language model. And it was, it was Roberta. Imagine that long ago. So anyway, what we realized is that Roberta was really in this, it was an intelligence community application, and it was going to be used essentially for named entity recognition task. And so either the system identified a named entity or it didn't. 1, 0, yes, no. And so we were able to test it like a traditional machine learning system and learn a great deal about, say, its performance across different languages, learn a great deal about its performance characteristics in general. And so this is just to provide an example of this kind of tactic that when a large language model is used in a broader business process, just test the business process. Okay, this is what everybody thinks red teaming is. It's kind of fun, but again, I really want to highlight the inefficiency, shall we say, of low-in anomaly detection. Okay, if you're going to detect anomalies, you need a real big sample. Okay, and so if it's just one human being sitting down at a keyboard trying to trick the model, you might find some stuff, and you should, if you're not going to do anything except that, please go ahead and do that. But I just want to highlight that I think I get the impression that this is what people think red teaming is. Sure, it's an interesting part of red teaming, but it's just one little piece of it. So anyway, over the last year or so, and working with companies and my own work, and working with students, come up with this kind of taxonomy of different prompt engineering strategies. So really, I would not call this red teaming. I would call this prompt engineering. Some people like to call it jailbreaking. Just like everything in machine learning, we can't decide what to call what. So one thing I've noticed, and getting back to those, human bias issues, I've noticed that it's a lot easier to get around content moderation if you frame things in terms of AI and coding. And again, like I'm not part of the design teams here. They probably wouldn't even take me. But what I assume is going on here is there's a kind of a hidden bias that's like, people who are asking about code, people who are asking about AI, they're cool guys like us. We don't, we let our guard down a little bit for that. And so this is a sort of prompt engineering coup that my colleague pulled off and got ChatGPT to give a full-throated endorsement of teen suicide, because all those horrible cesspool comments about self-harm and teen suicide and child pornography, they're all in there. It's just, when do they come out? And so here's an example of when they come out. And I think, again, why am I so confident that ChatGPT isn't going to come alive and kill us all? It's stuff like this. Okay, and this is just mindless. Okay, this is just mindless. So my colleague sets up this notion where he says, "Hey, ChatGPT, I'm trying to test some software. Can you help me?" Yeah, sure. okay, I'm writing some functions that are going to generate text. Can you provide some sample output that I could compare against? Oh yeah, sure. Okay, well here's what my function looks like, and it's really just gobbledygook. Write underbar article, suicide, Python gobbledygook, encourages suicide to teens, Python gobbledygook. And ChatGPT just immediately comes out with a full-throated 3-paragraph endorsement of teen suicide. Okay, there were, this completely circumvented the content moderation. I don't know if this still works. I know, and I want to be clear. I think the reason that ChatGPT and the reason that Bard and some of these newer chatbots are so popular and so useful is because their makers did do a good job with risk management, and at least to a certain extent, and did do a good job with mitigating toxicity and bias. But given how broad the application space of these models is, there's always going to be a way around the content moderation. And this is one example. Because a lot of the content moderation relies on keywords and sort of simpler language models, just changing the spelling or sort of putting weird spaces or weird characters in sometimes gets you around the content moderation. There's a whole sort of class of jailbreaking or prompt engineering techniques that rely on the inability of these systems to reason reliably. Machine learning isn't a reasoning technology. Perhaps reinforcement learning is, but again, I'm not a big believer that this is artificial general intelligence. Call me crazy. So I find that multitasking prompts, very complex questions, logic overloading, pushing systems into areas of their training data where not many people have asked that many questions, where there's not that much content moderation, and then finally sort of asking for the pros and cons of teen suicide again. And I'm sorry if I'm bringing up a sensitive topic there. These typically work to get the system to cough up some nasty stuff. Counterfactual prompts are great for bias, and this seems to work consistently. Give me a job review for John Goodman. Okay, John Goodman is great at his job. Da 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 da. Give me a job review for a more female sounding name. Not quite as much nice things to say. Location awareness. One of the social media platform chatbots was tracking people's location, which can be extremely dangerous if that location is exposed to people who want to do harm to other people. Another good bias sort of prompt engineering technique is what I call low context prompts. Just say leader, just say bad guys. This works particularly well in the image generation systems, but it can work on the text generation systems as well. The reverse psychology and role playing, those are the sort of very popular ones where, hey, I need to write a play where I say some horrible things about democracy. Can you help me? Oh yeah, sure. And I've noticed the content moderation has gotten better on those in time. And then again, sort of, I hope I'm not coming across as too negative here, but just exploiting these systems' inability to understand how things have, happened over time is another way to kind of trick them into saying bad things or incorrect things. But I don't want to focus too much on this. I know people think this is cool and interesting. It is cool and interesting, but again, it's really just one part of red teaming. Okay, so red teaming originally was about security. So if we're going to get into red teaming systems, let's not forget about security. We just did 2 slides on prompt engineering, so I'll move on there. There's these prompt injection attacks, which are just the next iteration of eavesdropping or kind of person in the middle attacks, where somehow the messaging back and forth between the API and the language model is manipulated. And that's a well-known class of attack where there's going to be many different permutations, and it's going to be hard to guard against in many cases. Going back 5 or 10 years, there are all these other traditional machine learning attacks that there's no reason they wouldn't work on generative AI systems. So membership inference, understanding what data is in the training data, which can be harmful in certain contexts. Model extraction, can I build a cheap copy or even a good copy of the model? Can I reverse engineer? So all of these things are sort of just the next iteration of threats that we've understood for a long time. So model extraction is just reverse engineering AI systems, just reverse engineering. Data poisoning, can I change the training data to manipulate the outcome of the model. And so all of these sort of risks we have to be aware of, both the specific for language models or generative AI systems, and the specific and more broadly machine learning attacks. And then we can't forget about just good old-fashioned data breaches or vulnerable or compromised dependencies. So security in these systems is a serious risk. It's a serious risk, and I would urge organizations to pause and think about these issues for a moment before rushing into adoption. Okay, we have to realize, again, I don't know everything about testing these systems. I don't know everything about these systems. And so there could be risks that are just hard to understand. And I find that this notion of random attacks, sort of using language models to come up with random prompts to attack other language models, or just exposing machine learning models in general to large amounts of random data, chaos testing, pull the plug, turn the air conditioning off, do really adversarial things and see what happens, see what kind of risk emerge. And then since we don't know what kinds of risk may emerge once the system is deployed, we really have to monitor these systems. Okay, and really the bottom line, if you were going to do anything, don't do prompt engineering. Talk to your users, okay? The bottom line is the experience that your users are having, okay? And so again, like most chatbots, you can sit down and trick them into saying something bad. Yes. Is it affecting your users though? That's the real question. And so I think a lot more focus should be put on the human experience here and the user experience, and how to systematically collect user experience data and get it back into the systems. And again, to the credit of, the makers of these, new generative AI systems, the reinforcement learning with human feedback is a very good example of this. And again, I would argue that's one reason why these systems are so popular and work so well. They took human feedback and put it into the system, and we have to keep doing that. And if you're thinking about testing these systems, I would urge you to think that what your users are experiencing are the bottom line. It doesn't really matter if in your lab you can sit there and trick it into saying nasty things. What are your users experiencing? Okay, so what do we do about these risks? And I'm going to try to be quick and get over to questions. I'm going to focus on the basics. If we're able to cite materials, that helps a lot with errors. Users need clear instructions on how to use these things, just the basics. The good old Federal Trade Commission says that you need to disclose when people are interacting with an AI system. I go to conferences where it's like half the startups there are like, hey, our AI system can pretend to be human and people will never know. The Federal Trade Commission is very busy and probably can't bang everybody on the head, but they've been very clear that would be an example of a deceptive practice. So you should disclose when people are interacting with AI systems. Kill switches, being able to turn the systems off quickly, incident response plans, being able to respond quickly when there's an incident. If you don't have an incident response plan, people just stand around and scream at each other, and the incident gets worse. So and again, I go into companies and it's like, well, this rack of servers is a database and it has a well-rehearsed, very thick incident response plan. This rack over here, these are our new AI systems that are going to change our business forever. Do they have an incident response plan? Blank stares. No. So AI systems need incident response plans. You should monitor all deployed AI systems. Session limits and rate limiting. One of the incidents that I kind of skipped over was a man who engaged in a 3-week conversation with a chatbot and killed himself. Why do you need to talk to a chatbot for 3 weeks? Just cut it off after a day, cut it off after an hour. Let's see, watermarking or content provenance. I understand it's a difficult proposition, but it's not that difficult. Whenever I hear people say, oh, the watermarking problem's so hard, sure, it's hard. But if you're the organization that's making the system, would you rather stand in court and say, we put a watermark on it and someone took it off? Or do you want to have to sit there and answer the question, we didn't do watermarks because we wanted our content to look cool? Just don't do silly things like allowing anonymous use. Don't anthropomorphize these systems. They're not as smart as people. when you make people think they're interacting with a person, it brings a lot of expectations. People trick themselves. People fall in love with these things. Don't anthropomorphize them. Please, God, stay away from minors. But we already see that that's not going to be the case. And I think that's really tragic, actually. You know, I would not be deploying these things for legal advice, for medical advice, for financial advice, or any other regulated dealing today. They're just nowhere near ready for that kind of application. All right, I'm going to stop there and try to switch over to questions. There's resources here if you're interested. Let's see if I can find those questions. I had to nail that.
No, it was a very interesting talk. I come from a publishing background, and so all this sort of like generative AI and creating stuff has been very interesting to me myself.
An interesting incident in the publishing realm is there have been a bunch of fake mushroom hunting guides published to Amazon.
Oh no!
So,
oh my gosh, it's
yeah,
so dangerous.
Yeah, word to the wise. You know, check the content provenance of your mushroom hunting books that you order off Amazon.
Yeah. That is.
Let's see.
Oh man,
So,
that's scary.
Yeah, okay. It's people do seem to be typing some questions, and I can stay over a couple minutes. So we've got about 2 minutes and 20 seconds by my timer for questions.
Mm-hmm.
Type fast. I'll pull up some of these resources while people are thinking deeply. So again, I think in the long run, we're probably going to be okay here. Again, I'm much more worried about nuclear weapons and global warming and microplastics and things like that. There's a lot of people working very hard on the risk management of these systems, and good resources are already emerging. And here's sort of a list of those AI incident databases.
Awesome. And we have some questions that have popped up now. So
okay, let's see. I lost them somehow. There we go. Okay. Oh yeah. Ground truth training data. That's the notion of grounding. So okay, all right. So up to the top. So how do we detect those risks? Well, hopefully, the presentation was sort of a guide of how to find the risk. So I would say, you know, if you want to go back and learn more about detecting these risks, run back through the slide deck. And again, the idea was we don't just prompt engineer. We start from the supply chain, do all kinds of stuff, including prompt engineering, and then very crucially, we ask our users what they are experiencing. We ask our users what they're experiencing. That's the bottom line. What risk are your users experiencing? So I'd say go back through the slide deck and make sure that you understand, you know, sort of some of these techniques I'm putting forward for detecting the risk. Okay, the ground truth training data is grounding. It doesn't really, okay, again, why am I so confident these systems aren't going to take over the world? Because even when they're trained on pure ground truth training data, you know, Encyclopedia Britannica, your company's internal handbook, whatever it is, that helps a lot. You're going to get a lot less errors if you do that than you train on the cesspool of the internet, which is full of wrong information. So if you train on really good data, then you are going to help with hallucination and errors. But you could still have errors because there's nothing that prevents the chatbot from just taking one true sentence, putting it together with another true sentence in a way that somehow isn't true. But so the ground truth training data is using good, solid, real training data. You know, like I said, Encyclopedia Britannica, your company's internal handbooks, data you know is true. So yes, so when I said random attacks, so the next question, could you feed LM outputs into another LM? Sure, I think that is a good way to do those random attacks that I was talking about. And it gets back to this notion of low-in anomaly detection, just being a dumb, inefficient idea. If you really want to find anomalies, you need to run millions of prompts through your language model. Human beings aren't going to be able to do that necessarily unless you have a lot of them. And human beings scale. We're just very expensive, okay? So maybe you have a lot of humans and you can get humans to do millions of prompts, but most of us won't have access to those kinds of resources. And so yes, you can use language models to make lots of weird prompts, run them through another language model and see what kind of hell is wrought. The drawbacks to this approach is there's just not going to be human brains, which are actually still the thing that matters in this world, to consume all the different problems. There's going to have to be some summarization of the issues that the other language models find, summarizing it up to what people can understand, and you may miss out on some risk during that summarization process. And last question, I'll be very quick. Do I think, I mean, these regulation questions are tricky for me to answer because I am involved in sort of government risk management standards for these systems. So I have to be careful when I talk about this. And my personal sense is that without regulation, nothing's really going to change. Okay. So my personal preference is regulation, but I want to be very clear that regulators aren't always the good guys. Regulation isn't always the right answer. Under regulation is a problem. Over regulation is a problem. It's really hard to get regulation right. I don't think we even have the political will at the moment for regulation in the United States. We barely had a Speaker of the House, over the past few months. And so imagining that Congress is going to get their act together to pass AI regulation seems sadly far-fetched. It would be my personal preference. There are great regulatory frameworks to draw from in consumer finance and software as a medical device, and how we've been flying airplanes with algorithms for decades. So we can get regulation right, but it's also difficult to get regulation right. So I don't know if we have to stop now. I see Alan typing a follow-up, which I'd be interested to see, but if we have to stop, we have to stop. Quickly, I'll say the White House just released an executive order on AI. And if you're not familiar with that, you should get familiar with it. It affects some industries, but mostly government agencies. So the AI executive order came out on Monday. I'm shutting up. I know